So Algebra 2 students, we are going to go through each one of these quizzes as they are your number one priority in preparation for the test, and then we'll do some of the problems on the review. I want you to pay special attention to the first two quizzes. It's been a while. We learned this stuff before the long weekend. And there's some questions on your test, lots of questions from this stuff. Whoops. So, let's get started. Before you get started, you should have like the basics of your exponent rules down. Here are the following rules. I'm going to give like a easy example that you should write down, like 2x squared times 3x cubed. If I were to multiply all these together, the numbers would multiply together to get 6. But when you multiply all the x's together, you'd add the exponents. It's 5. That's 2 plus 3, which gives us 5. If I have a power to a power, you take the number to the power using your calculator. 2 cubed is 8. But then x squared 3 times, you'd multiply the powers to get 6. If I was dividing powers, I would cancel the amount that I have. You end up subtracting the powers, and wherever you had more of is where you're going to end up with powers left over. So there's that, and then this one would just be x cubed over 1. And then the final one would be a negative exponent is the same as the positive exponent in a flipped position. So the x cubed would move down, but the 2 would stay. If it was 1 over 2x to the negative 3, then the 2 would stay down, but the x cubed would move up, okay? So these are the basic exponent rules that you need to know. Only thing different is if you have any kind of rational power, you just use your exponents rules versus like maybe writing it out and figuring it out. So for example, this is a cubed root. So 27x to the 6th and y to the 9th are all going to be taken to the 1/3 power. 27 to the 1/3, I would type that into my calculator. Again, you can use your calculator to help you with numbers versus using rules. 27 to the 1/3 is 3. And there's that 3. But then I have x to the 6th to the 1/3. I have y to the 9th to the 1/3. Multiply 6 and 1/3, you get 2. Multiply 9 and 1/3, you get 3. So this would be x squared y cubed. Okay. We need to remember how to simplify radicals. Looking for the biggest perfect square that goes into 75. Remember, some of the perfect squares are like 4, 9, 25, because the square root of 4 is 2, the square root of 9 is 3, the square root of 25 is 5. Don't forget about the square root of 16 is 4. And you're just going to start dividing 75 by all those numbers until you find the biggest one. 25 is 25 is the biggest one. So 25 times 3 is 75. So root 25 times root 3 is root 75. This is 5. This is root 3. You can't simplify root 3. So 5 root 3 would be my answer. $12x to the 4th over 2x to the 6th. Again, your calculator can do the numbers as you see them. You need to use exponent rules to figure out what goes on with the exponents. So the 12 divided by 2 is the 6. Now, x to the 4th over x to the 6th is one of these situations where I'd cancel 4 x's, leaving us with a 1 up top. Cancel 4 x's, leaving us with 2 x's in the bottom. So this is why I end up with x squared on the bottom. Very similar to this one, the numbers get multiplied, I get 6. The x's get added in terms of how many you're multiplying, so this would be 6x to the 7th. This would be 6x to the 6th. This is 5 and 12. 5 x's, 12 in the numbers, 12 and then 7 x's. Pretty simple, that one. Here, it's a 1/2 power. So I got 9 to the 1/2, I got x squared to the 1/2, and I got y to the 6th to the 1/2. 9 to the 1/2 is 3. X squared to the 1/2 is x to the 1st. Y to the 6th to the 1/2 is 6 times a half. Again, you're using this exponent rule of power to a power, multiply the powers, get y cubed. So I get x to the 1st, y cubed. Two cubed, x cubed, cubed. 2 cubed plugged into your calculator is 8. Another simple one, x to the 6th to the 1/2, power to a power, multiply the powers, x cubed. And then finally this negative exponent, 3 stays, the x squared moves down. Don't write this as 1 over 3x squared. The 3 is not taken to the power. It's just the x. If this was in parentheses, then yes, you'd move both of them down, but it's not. So it's just the x that's being taken to the power. Now, some things I'd want you to worry about for your test are the following questions from your review. (10) and 14. Why? Because you will have multiple choice answers to select. Now the square root of 9 is 3, or 9 to the 1/2 is 3. But if you multiply 5 and a half, it's 5 halves. You multiply 7 and a half, it's 7 halves. Now, I'd be okay with this as an answer, and you'll get like most of the credit if you got this and did not know what to do from this. But there are some questions that you're going to see where this is not the answer that you're going to see selected. And this is how I want you to think about this. 5 halves, if you type it into your calculator as a decimal, is 2.5. 7 halves is 3.5. Why do I do that? Because we can have 2 x's and another half of an x. So x squared times root x is x to the 2 and a half. Y to the 3.5 is y cubed times the root of y. That's 3.5. You would probably see this answer choice on your test. Didn't think it was going to show up on the test, but I think it's going to. But I think we'll be okay with it, and we'll make sure we review it. So same thing here. Square root of 25 is 5. This is x to the 3 halves. This is y to the 3rd. 6 halves is 3, so we can simplify that. But 3 halves is 1.5. So this would be x to the 1st times x to the 1/2. And this would be your answer. Or another version of this would be 5x y cubed root x. Okay? So make sure we're comfortable with those questions. Questions like 13, easier to do because everything's going to simplify. Let's go to the second quiz. Still have our exponent rules up here. Now we just have these rational exponents, but the same rules apply, where it's just take your numbers and plug it into your calculator as you see them. Take your x's and your y's and use exponent rules. Now you can use your calculator to help you do this, but you got to make sure you're doing it the correct way. For 8 to the 2/3, I just type it in as I see it. I get 4. But x cubed to the 2/3, I'm not going to type in 3 to the 2/3 because it's not that. I'm going to use the exponent rule of a power to a power, you multiply the powers. So I'm going to do 3 times 2/3. And get 2. I'm going to do 6 times 2/3. To get 4. Okay, that's the key to exponent rules. Numbers can be typed in as you see them. Use exponent rules to help you figure out what to type into your calculator for those. So 4x squared y to the 4th. This is a great one. You're going to see this on your test, something just like this. It's x squared to the 1/3 to the 6th. Now, the rule still applies if you have multiple powers going on. You can multiply all of these exponents together, 2 and 1/3 and 6. And you get x to the 4th. That's the answer. If you wanted to split this up and do this first, which is x to the 2/3, and then multiply by 6, that's fine. It's up to you. You can do it all at once. You can split it up and do a couple pieces at the same time. It'll work. Now, this is a good one because it combines two rules. We haven't kind of looked at this rule in a while, but we're going to use it. Because the first things first, I'm going to rewrite this as x to the 7/3 and x to the 5/3. Now, when you are multiplying x to powers together, you add. This 2 plus 3 is the 5. I'm going to add 7/3 and 5/3 here. Oops. And you get 4 again. 7/3 plus 5/3 is 12/3. 12/3 is 4. Okay, now we need to be able to go both ways, whether you have a rational exponent and you turn it into radical form or vice versa. Easiest thing to do is just to remember like power to a power. Like the 3 is going to end up on the bottom. This 1/3 is a cubed root. The 2 is going to end up on the top. So this is like the same as x squared cube rooted. And then this would be x cubed square rooted. This would be x cubed 4th rooted, and this would be x to the 4th cube rooted. Again, to show you how you get that, x cubed to the 1/2, x cubed to the 1/4, x to the 4th to the 1/3. This is a good one. There's multiple ways to do it, but let's just assume like what you've always done when you see powers to powers is you always take everything to the power. So you got 64 to the 1/3. You get 4. You get 8 to the 1/3, which is 2. And you got x to the 9th to the 1/3. Again, multiply using the exponent rule to get x cubed. Now you realize you got 4 divided by 2. Well, you could do 4 divided by 2 and get just 2. So, the correct answer to this is 2x cubed. I have x to the 1/2 cubed, well, multiply those together, you get 3/2, x to the 3/2. Another good one where we are combining rules. We'd start as writing this as x to the 5/2, and this is x to the 3/2. What has more? 5/2 is more than 3/2. You're going to cancel out all these 3/2, take them away from the 5/2. 5/2 minus 3/2 is 1. Five halves minus 3/2, 2/2. Okay, so that's this quiz. Moving on to the most recent quizzes, I think we're going to have a better time with these. They're a little bit more fresh in our brains, whether it's graphing or solving. Now, for graphing and for transformations, some things we have to remember. Inside a square root affects the x's, and it does it the opposite of what you think. Outside is going to affect the y's, and it's going to be normal. The square root graph is only going to be from 0 to infinity for our x's. This is our domain. And the range is going to be 0 to infinity. That's our y's. For the cubed root graph, domain and range will always be infinity to infinity, so we don't have to worry about transformations. We'll just have to worry, we don't have to worry about shifting our domain and the range. We'll just have to worry about our transformations. So what do we see here? I go to the right one, which will be adding 1 to the x's, and I'm going up 2, which will be adding 2 to the y's. I'll take the domain and range of root x, add 1 to the x's. It'll be 1 to infinity plus 1, which is 1 to infinity. Add 2 to the y's, it's 2 to the infinity plus 2, or 2 to the infinity. So the domain is 1 to the infinity, range is 2 to infinity. Don't worry about solving things graphically. You won't be tested on this. I'd ask you to solve this on the next quiz. Domain range for the cubed root is always going to be negative infinity to infinity. You will have Desmos for these problems, so you can check things. Here you can see we're going up 2, but we got this negative x. When you have a negative, you're going to reflect things. You're going to reflect your x's. Now, when you reflect your x's, instead of having your x's go this way, they're going to go the other way. So I'm going to go up 2 and go the other way for my x's. Now, when I reflect things that way, it reflects them over the y-axis. So over the y-axis, not over the x-axis. Over the x-axis would reflect things vertically, okay? A lot of people messed up on that on their quiz. Here from F to G, I shift to the right 3, and then I go down 2. If I were to write an equation for this, right 3 is not x plus 3, but x minus 3. Inside, x is opposite. Down 2, so minus 3, minus 2 would be my answer. What would be my transformations? Right 3, down 2. Be ready to write the equation for your graph based on the transformation, and that's what we get. All right, and then we'll finish off with the last quiz. I don't have time to put the video together for the review. However, the quizzes are the most important thing, besides those couple extra problems that I showed you. So as long as we're understanding these quizzes, we are good for the most part, except for those couple questions that I showed you from your review. I'll do a couple more, maybe transformations right here. For example, you have a negative on the outside and a 5 on the outside. So the 5 on the outside means up 5. The negative means we're going to flip our y's, which means we reflect over the x-axis. If your y's go from here to down here, you reflect over the x-axis. I'm also going to shift to the right 3. How will that affect my domain? Since I'm shifting to the right 3, my domain will be 3 to infinity. My range, I start with 0 to infinity. I add 5 to everything, but then I flip things. So we end up with negative infinity to 5 because I'm going to go up to 5, but then I'm going to go down with my graph. Is it unit 7 or unit 8? Okay, this one would be left 1, down 2. Domain would be negative 1 to infinity. The range would be negative 2 to infinity. Here, this is a reflect over the y-axis because it's inside, it's affecting the x's. The x's are going to flip over the y-axis, and we're going to go down 1. The domain and range are both going to be negative infinity to infinity because you can't really add or change these. It'll still stay the same. This will be left 2, down 1. Infinity to infinity. Writing equations, I am going to the right 5 inside x's opposite, up 2. I'm going across the y-axis. When you reflect across the y-axis, you change your x's. So I'm going to flip these and transfer it left. I don't like having the left and the flip. It's a little bit confusing with that. I probably would say 3 units down and reflect over the y-axis. So like that. Up to left 3. Inside opposite, outside normal. Up is the y's, left and right are the x's. Reflected over the x-axis changes your y's. I need a negative on the outside. Right 2. Okay. All right, let's finish off with the last quiz. Tell me the order of operations for this. So for solving equations with radicals, here's the key. Flipped exponents undo exponents. So a cube will eventually undo the 1/3, but we need to isolate our exponent first. So we may have to do some stuff like add 2 to both sides. Divide by 10 to get the exponent by itself. Flip the exponent to both sides to undo. Gets rid of this. You don't have to do anything on the left side. You just have x plus 2. On the right side, you need to do 2 cubed. 2 cubed is 8. Finish off by subtracting 2 from both sides. Okay. Isolate the exponent. Use a flipped exponent. exponent up.
I'm good. How about you? I'm ready.
Good. Good. Not many people have been.
Really?
Yep. Sometimes you won't have to do anything to isolate the exponent. Did you take a picture and everything?
Yeah, I did.
All right, thanks.
I mean, I did for the uploading part, but did you want to see the other part for the?
No. So since the exponent's isolated, I can go straight to getting rid of it. I don't know what 64 to the 2/3 is, so I'll use my calculator to do it. And I get x plus 12 equals 16. I'm going to finish off by subtracting 12, and I get x equals 4. Don't like this question. It won't be set up this funky. Instead, you'll always have the root isolated. So it's set up like this. Now you'll have a question like this on your test, where a root is isolated, it's a 1/2 power, and the first thing you can do is really just square both sides. Now most students think that this is x squared minus 49, or x squared plus 49, but you're wrong. If you were to square x minus 7, that is x minus 7 times x minus 7. And I would actually fill in a box to figure out what it is. I get x squared minus 7x minus 7x and plus 49. Adding everything together, you get x squared minus 14x plus 49. What do I do now? Well, this is a quadratic. We practice this in class, where we need to set things equal to 0. Leave your x squared as positive on the right side. Get rid of the x and the minus 1 by subtracting x and adding 1. You can only subtract x from this x. You can only add 1 to that, giving me x squared minus 15x plus 50. We got to think of two numbers that multiply to get 50 and add to get negative 15. It's 10 and 5. We're doing our big x squared number puzzle here. Negative 10 and negative 5. Add to get negative 15 and multiply to get 50. So I get x minus 10. I get x minus 5. Which means my solutions are what make this 0, positive 5, and positive 10. Now, when we are squaring equations, sometimes we'll get solutions that we think are correct, but actually do not work. Go back into the original equation. And if we plug in 5, 5 minus 7 is negative 2. 5 minus 1 is 4. The square root of 4 is 2, not negative 2. You type in the square root of 4 into your calculator, you get positive 2. But 5 minus 7 is negative 2. So this is where we have what's called an extraneous or a fake solution. A solution that we think works, but turns out doesn't. On your quiz, on your test, you'll be asked, what is the real solution? What is the extraneous solution? 5 is the extraneous solution. 10 is the real solution. 10 minus 1 is 9. Square root of 9 is 3. 10 minus 7 is 3. That's the hardest question. That's like the last question on your test. You ready for that? This is not as hard because you have two square roots, both isolated. When you square both sides, it goes away. This is just solving an equation with x's on both sides. Get your x's on one side, get your numbers on the other. Okay. All right. Let's do one more. Couple more. 36. Isolate the exponent. Take both sides to the flipped power. Type the right side into your calculator. I think that's 64. Since you're square rooting, to solve an equation, you need a plus or minus. I don't think this shows up on your test. If it does, don't worry if you don't put it. 16 to the 3 halves. Yeah, 64. Yeah, why don't we do 42 or 43? Square root's isolated, ready to square both sides. To square x plus 2, you need to find the square of x plus 2. This becomes x plus 22. This is x squared plus 4x plus 4. Subtract the x, subtract the 22. I get 3x and negative 18. The two numbers that multiply to get negative 18 and add to get 3 are 6 and 3, positive 6 and negative 3. So x plus 6, x minus 3, giving me solutions negative 6, positive 3. Negative 6, extraneous. Negative 6 plus 2 is negative 4. You can't have a square root equal to a negative. Square both sides. This is just 2x minus 14 to square x minus 7. You get x squared minus 7x minus 7x plus 49. Plus 49. Subtract the 2x, add the 14. Subtract the 2x, add the 14. X squared minus 16x plus 63. I gotta use my calculator for this. Factors of 63, 21 and 3. Nine and 7 work. Negative 9, negative 7. I guess I could do it down here. Giving me x minus 9, x minus 7. Now this is a tricky one because we get two solutions, 7 and 9. We think the smaller one's probably not going to work, but in reality it does. 7 minus 7 is 0. The square root of 0 is 0, so actually both work. On your tests, letting you know that in these situations you're always going to have one that doesn't work, but it's always good to check. Okay? All right, that covers most of them. We do a couple others in your quiz, like for example, there's just one that's square root of 5x plus 6 equals x. When you square this, you get 5x plus 6. You don't have to do anything crazy on the right side. You get x squared. Subtract the 5x, subtract the 6. Negative 6, positive 1. Factors, which means my solutions are negative 1 and positive 6. Negative 1 is extraneous. All right? That'll do it for the review video. Make sure you do those quizzes again. Make sure you understand everything. Come in with questions, and I'll see you out there.